Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain, and I want to welcome you to this special presentation. AI-powered dynamic slotting drives continuous warehouse optimization, presented by Lucas Systems. Now, slotting has a big impact on warehouse key performance indicators: productivity, shipping accuracy, inventory accuracy, warehouse order cycle time, and storage density. Yet typical warehouses have less than a third of items located in optimal locations. So in this session, we're going to uncover ways to transform your slotting process, making it more dynamic by using AI to eliminate the time-consuming engineering and manual modeling required for traditional warehouse slotting systems. We'll show you a game-changing way to make slotting smart, simple, and real-time, so you get the benefits of reslotting as often as you want.
So what I'm going to take you guys through here is a little description about what slotting is, what machine learning is, a brief description, and then how we combine the two to provide value and optimization into the warehouse and give you some strategies that, going forward. So the DC landscape continues to change and become more competitive. When looking at the smiling elephant in the room, Amazon, they've invested billions in distribution operations, added scores of new facilities every year, and aggressively invested in technology. Industry best fulfillment was critical to their strategy because fast, free delivery was seen as a competitive advantage. But now that's not even related just to direct to consumer as a retailer. Amazon is taking more B2B market share as well. So nearly everyone is competing with them. So how can you adapt? To adapt to the threat, companies have changed their thinking from thinking about distribution as a cost center to thinking about distribution as a competitive advantage. Effective, efficient DC operations help you compete in today's markets and enter new ones. So you cannot weigh every DC investment on its ability to just reduce short-term costs. They've also moved from continuous improvement focus on incremental process change to continuous optimization and operational transformation. DCs need tools that have helped them manage the week-to-week, day-to-day, and hour-to-hour changes that occur in the DC. That means dynamic optimization. From large sales systems that serve your business unchanged for the next decade, they've moved to more agile next-generation technologies built to support change. A simple example is moving from more capital-intensive fixed installations to flexible systems that leverage software and other agile techniques. What are the challenges they're trying to face into? Obviously we have the e-com spike, really accelerated by the pandemic, what was already occurring. Those increased volumes put new stress on operations. It's not just e-com as well. It's, retail and store fulfillment orders becoming smaller as sites try to better optimize their commercial square footage. Increased SKU mix because of customer preference and these smaller orders leads to excessive travel around the warehouse, whether it's walking, driving, or even just the automation itself, like robots and conveyors. We see inefficient task workflows as well for end users. So sites have tried to shoehorn these new kind of processes, customers, new order types into existing processes and software packages, which can cause some major inefficiencies. Lastly, unpredictability. It's harder and harder to plan out your day, your week, your year ahead of you because unpredictable order volume spikes and changes, and even staffing levels as well. So, we've all seen that happen out in the industry. So there are a myriad of problems and ways to address them, but today's focus is on one particular methodology, and that is slotting. So what is slotting? I'm going to try to give you a very simple definition to kind of anchor to today. Take all complaints up with Bob. Don't ask me. The act of slotting is the act of trying to determine which products should be in your locations and slots in your warehouse. It's also making sure that the slots you have enough product capacity to meet expected demand. So, right sizing the slots and the products with the demand that you have. How does it typically work? It's usually done infrequently, if at all. So a person, usually one or two or a team of engineers, tries to determine new locations and matches for products. And then there's a physical move of those products and swaps or changes throughout the warehouse. For most warehouses, this happens, once or twice a year, if ever. Some are doing it much more frequently, but generally that's the kind of status quo. Why does it take so long? Why is it done so infrequently? One is it's hard. It's a hard problem. It's time consuming to figure out where to put things. It's hard to figure out, am I looking at the right data at all? Am I bringing in the right considerations? What makes the slot good or bad? You also typically it involves an FTE who has a normal, day job that doesn't necessarily involve slotting. So they're running the warehouse, they're managing inventory levels in general. So you're kind of diverting FTE resources. So it ends up being pretty expensive. You also a lot of slotting packages or planning strategies revolve around shutting down picking or doing moves when an off hour. So you have to work overtime to actually execute the moves. Lastly, even if I do the moves, I take the time to do it, I make the changes happen. My ROIs could be bad in a few months, right? So if I have a highly seasonal warehouse, it might not feel worth it to move everything every month because in 3 months it's going to be bad. So you just let things drain out and go with what you have. We're going to look at a new approach to this problem using AI and machine learning technologies. Right now, I imagine the most common sliding, what I imagine, I know the most common sliding tool used out in the world is Excel, right? Which is great, but we think there's a better way, there's a better mousetrap than just simply Excel. We want to eliminate the engineering and manual modeling required for traditional warehouse systems. We want to use AI to create a robust sliding model using the spatial characteristics of the DC and the product order profile to predict optimal placement of products. And we want to utilize machine learning to continuously adapt to the DC and evolve as conditions change. So artificial intelligence is simply the engineering of machines that mimic human cognitive functions. Very broad definition, somewhat intentionally so. There's a lot of different definitions of AI. It's gotten more muddled with the proliferation of ChatGPT and other generative AI tools. But really, we're looking at anything that mimics human cognitive function. Within that, we have machine learning, which is a technique within AI in which a computer is programmed with algorithms designed to learn from data examples. And then you have deep learning, which is a type of machine learning. It is based on an approach called artificial neural networks. As the name implies, it was inspired how our brains are architected. So how does it work in this context? So essentially what we want to do is take the right data. So that's data from automation, so that could be conveyors, they could be robot data, and then data from devices like RFs or voice picking units. And take all that and leverage it and bring it all together and combine it with IoT data, like what day of the week is it, what month is it, seasonality, other external factors. We use all those together and create a machine learning model used to try to find new variables, understand what variables are predictive and not predictive, and essentially create recommendations and predictions. What our engine does is take those recommendations and predictions and get them directly to managers and engineers. So in the past, companies relied on data analysts and other IT resources to develop analytic tools for use in business. This tool, what we hope to do, brings those insights directly to the end users who will interpret and implement those recommendations. We think machine learning techniques are going to fundamentally change how companies perform certain key optimizations, empower things like dynamic slotting, workforce planning, labor planning, and performance management. When looking at the machine learning versus the typical engineered slotting approach, or even just extending past slotting to workforce planning and other techniques. The engineered approach is great, but it can be costly and it can be manual and static. So when I think of the very simple example here is look at is say engineered labor standards. To do that, I have to bring an engineer or two or many on site, do time studies, do motion studies, and figure out how certain tasks should be fulfilled. I could also, create business rules and create an entire rules engine around labor standards to help build this model, which is great. The problem is it's detailed and it's static. If things change, you're looking at reactive and historical data, and it's hard to keep up with the ever-changing DC. The rules engines can be brittle because as you add more rules, you start to contradict each other. And again, you can't react to simple changes, right? So if I say I got a whole new fleet of pallet jacks and they go 10% faster, well, theoretically, my labor standards should change. But am I going to pay for an engineer to come out and do another time study? Probably not. Maybe I should. And things start to kind of fall down. The Conversely, the machine learning approach is all built with the idea of adaptability and reinforcement learning built into it. Some of these things are things you simply cannot do without machine learning. Besides trivial problems, specific coding instructions can become impossible and contradictory, and you really need to build in feedback loops into your models to be able to sustain over changes. Our new approach, based on AI and machine learning, to this problem of placing the best products in the warehouse. So when looking at a traditional approach, what do? You first build a scaled model of the warehouse to try to estimate travel cost. So that might be as simply as Excel, like an Excel map of the warehouse. But if you look at more robust packages, you might be making full 3D models of the entire DC. You need to have solid queue of each and every product in each and every slot in order for it to work fully. And you need to build and constantly tune optimization models and weighings in the system in order to calculate savings or potential recommendations. Then you need to periodically continue to reslot products. Many of the different engines require you to slot things dependently. So you have to do everything all at once, or some chunk all at once, or an entire zone all at once, which can add to the cost and the rigidity. What's the machine learning approach look like? Essentially, we want to learn the cost of current operations from existing data. We want to identify suboptimal product slotting and then give recommendations to users for new slotting options, especially focus on the heavy hitters. And then power a way and a process to do dynamic reslotting, or what I like to call opportunistic reslotting, in order to continually bite off what you can chew to make moves and get ROI. We have a few different objectives here with the system that we're trying to attack. One, the first one, that dollar sign, right? We want to reduce picking and replenishment costs in the warehouse. We want to reduce inventory damage. We want to improve space utilization, better cube out the facilities we do have. We want to improve worker ergonomics and safety. We'll talk a little bit about golden zone slotting and other ways to mitigate that, as well as improve picking accuracy. There are a lot of different factors that could be taken into account when you think about slotting. Here's a brief look at a lot of different ones, from the handling unit appearance to the style of picking you use there, compatibility, seasonality, all that. You have a lot of different objectives as well. Because of this, you have thousands of SKUs in locations as well. This makes for what is called a combinatorial optimization problem and a multi-objective optimization problem, which in ordinary terms means it's a very difficult problem to solve with a very large set of possible solutions. Also, once you do solve it, SKU profiles and other inputs change so rapidly that you might have something that doesn't work when your order mix changes significantly. So these, taking all these into account, these are perfect solutions and perfect problems to ask of machine learning and AI. What variables do we take into account? What are our key ones that we're focusing on? So we have a machine learning model, so we can take a lot of things into account, but we like to talk about these 6 variables. So first and foremost, most commonly, is velocity. So how fast are products being picked? How often are they being picked? And then what quantities? One we also look at is affinity. And we'll talk a little bit more about that, but that is one that has come up much more in our production usage of this solution. And that one that simply can't be captured by things like Excel. We also look at seasonality, which are really, really important in some warehouses, and some customers of mine come right to mind, and not so much in others, but there still is some impact. Along with seasonality, you might even look at day-to-day seasonality, right? So things within a week. My Mondays are busier because we're closed on the weekends, for instance. That takes things into account. A lot of our customers specifically and a lot of operations are leveraging ways to do order batching. So we want to take that into account and consider that and kind of make a robust affinity model. We look at SKU compatibility with slots. The simple example of this is, if I have a product that's supposed to be in a freezer, well, kind of has to go in the freezer. It's incompatible with the ambient chamber. And then we look at dimensions. So the product and slot dimensions as well. We can do this as detailed or as simple as the DC allows and the data is there. But these are the main 6 factors we're looking at. Machine learning is designed to continuously ingest data. This solution is built to automatically handle change. With an occasional one slot or total reslot approach, unfortunately, the optimized state sort of deteriorates quicker than you think due to those changing conditions. Traditional software solutions for slotting put users through a lot of configuration pain and guesswork. So we really want to simplify that and make the end user UI tool that is easy for anyone to consume. We want to take advantage of, if we can, forecasting, right? So we want to be able to ingest forecasts. That could be long-term forecasts. I think of a sporting goods apparel retailer. They know what they made for the year. They have merchandisers who spend an entire part of the company who work on that. We want to be able to ingest that. We also want to be able to ingest something simple as they put this product on sale next week in the penny saver. So we want to be able to take those things and make proactive changes. And then we want to be able to improve productivity, efficiency, and safety with horizontal and vertical sliding optimization. So again, thinking more about that golden zone, thinking about travel distance, both walking, driving, and then vertical up and down if I'm picking things on a cherry picker, and take those into account as well. All in all, this ends up spitting out an ROI and an explanation in our UI, which we'll show a little bit later, but we think that helps motivate action in the DC. What are some of the benefits of these aims, these variables, these optimizations? So improve space utilization, right? So getting products in appropriately sized slots will allow you to store more inventory, allows you to store more SKUs in a better, more efficient way, and hopefully, require less racking or less, additional warehouses needed. Reduce the replan and picking costs. So that's usually the headline for slotting. So you want to reduce the travel distance you spend to pick orders. You want to reduce the amount of replenishments I have to do by getting things into the right slots with the right size, and then enhance safety and ergonomics. You want to move frequently picked products, to the golden zone. So areas between the knees and shoulders are where your most often picked products are. You want to move heavy items away from top shelves because you don't want to reach above and grab heavy items that causes injuries, but you also don't want to be bending down all day at the lowest items in the ground. So you want to take that into account as well. So what do we need to do this? That's usually the first question people ask. So first thing, we start with a warehouse map. We can take a very simple map and build our digital map of the warehouse. You don't need to have a full AutoCAD with every pillar and post labeled. You don't need to have a 3D model. I've literally built these warehouse maps with it mounts to the back of a napkin. As long as I know where all the aisles and bays and levels are, we can start from there, and then we can build up and build compatibility from there. We also connect to a data source. So most commonly, that'll be a WMS. Could be an ERP. We also want to connect to Jennifer if it's in use at the site. It is standalone. You don't have to use Jennifer picking to take advantage of slotting, but you will get more robust data from the picking and replan activity. And we also create a method just to do simple file uploads. So that might be, again, for like product forecasts that aren't as ongoing or routine, or for some reason you can't set up a WMS integration and we don't want to go through that cost and burden. We could do a simple file upload. We want to be able to collect this data on a recurring basis. So we want that slot and product info and want to know where everything is at the moment. We want to get that replan and picking activity because that feeds into our cost algorithms. And so we know if you travel from here to here and it took this long, then we want to take that into account in our machine learning model. And then we want, compatibility matrix. We need to keep that updated. So that is, what new SKUs come in, what locations can they fit in, what locations can't they, things like that. Essentially, we take those things, we throw it to the cloud. We feed it into our cloud-based AI engine, which provides the swaps for the actual move, so the recommendations. Users can request as many swaps as they want, as often as they want. It's an on-demand type model. They can then decide to commit or reject those swaps. When you commit them, we can send them to the WMS directly. So we can send and essentially create an integration to create, what amounts to like a bin-to-bin move to swap those locations. We can also, if we want to set up an integration to update, masters or other data to change picking locations, that's possible as well. But a lot of WMSs don't like other systems touching master data. So in those instances, we can export to a file and develop things a different way. We can export to Jennifer to make actual physical moves, or print them out on paper if you have to, if that's the only way that you can feasibly do it. The idea here is, again, power and simplicity combined, right? We want to make this a super easy UI to use and leverage. And we want to differentiate from some of the more complex packages that require an industrial engineer to be able to run. I want my end supervisors in the warehouse to be able to use this product, or really anyone. Requesting recommendations is pretty simple. You simply have to hit the request button and the system asks you for a number of recommendations. The idea here is it's towards the end of a shift. My replan guys are all wrapped up. They have about an hour left, and I was going to send them to go clean, maybe do some training, things like that. So I have time for say 10 moves. Instead of doing that cleaning, maybe they can do those 10 moves. I can decide to make them independent or dependent. So we'll see that in some slotting packages, if you guys have seen that before, where I can say, I know I'm going to do all 10 of these moves and execute them. So I can make these moves dependent, which will take advantage of, say, more affinity style reasons. So I can maybe two products that have been getting picked a lot together. I want to move those both to the front and swap them out with two other products. So I would make those dependent changes. Or I can say, I don't know how long, my gal on the replan trunk is going to take to do each of these. So I'm going to say they're independent. They don't make them dependent on each other, and click request, and those will spit those out. Then the system will work for a second and then spit out some replan recommendations from the cloud. So this is a full web-based UI. So it is, you don't have to install software on a local machine, or you can run it on a tablet. You see people on equipment running tablets directly. They could run it right from their machine theoretically. So you can see the slot and SKUs here, and just very simply say from slot 1, this product, the air filter for Kawasaki, to move over to slot 2. The reason code for that, in plain English, this will cause or result in a replenishment cost reduction. So this likely means that this product that's getting moved to the front is being picked much more often, and it needs to go in a bigger slot because we're replenishing it too often. We calculate a reslot cost, which will, the travel time and time it takes to execute the move. And eventually the end goal is to spit out an ROI. So if I execute this move, I will make my money back in 4 days. So it feels like a no-brainer to do. You can have other reslot reasons, like a product affinity that, like I mentioned earlier, that's one that is coming up much more often than we initially expected, and is one that's really hard to kind of calculate with Excel or any kind of simple product velocity based module. But a number of other reslot recommendations there as well. In addition to that, we generate heat maps. We can look at a few different metrics and color palettes. So here I'm looking at picks on a uniform distribution, and I can see My blades area here is really hot, but I expect that. That's what we sell the most of, and those are my optimum slots, so that's fine. I see some red way back here in the top of the warehouse. I might want to think about moving those products to a more optimum slot if possible. I can change color palettes. So if somebody is red, green, colorblind, we have a few different palettes built in or just wants to stylize it differently. And I can look at different metrics as well. So here I'm looking at replen visits. I can look at different distributions. So if I want to see rapid changes, I can look at the logarithmic distribution and other configurations there. We do allow you to do what if recommendations. So if I know a product's coming in, I upload a forecast and I want to see if it makes sense to move it to the front or move it to an optimal slot. I can ask the system, is there a better slot for this product? What would happen if I did this swap? Another thing very important as we talk about that continuous optimization is providing user feedback to the model. So if I reject a recommendation, for instance, I can give a reason for that recommendation, and the AI engine will incorporate that feedback. Most simple example is I get a product, a new SKU in. The product master says it's one size. When the user goes to try to do the swap, it doesn't work. So we reject that recommendation, and now the AI engine incorporates that and says, "Hey, maybe this product size is wrong. I won't recommend that type of slot again." We can also implement custom columns and show things like current stock levels. So you might want to wait till a slot goes down to 0 before you make a move, makes the move cheaper. Whether there's any orders allocated against a slot, things like that, whatever you can dream of that makes sense, we can implement that as a custom column for your client version.